So if, like me, you live stream, you've probably come across problems with camera placement. So in today's video, we're making a camera rig. So I live stream my projects on Twitch, and all of the magic happens here on my workbench. And the challenge I've got is getting a good camera placement. Very often the camera is either in an awkward position or it's precariously placed and ends up falling over. So I need a solution that allows me to move my camera from place to place to be able to get a top-down shot or a reverse view shot. So I need something which is reasonably flexible. So after doing a bit of research, I came across these microphone stands, really inexpensive. So there are other solutions which take up quite a large amount of space, like a bridge over the top of the desk with a camera placement on it. Now that has its advantages because it's more rigid, but I need something that takes up less room. As you can see here, I'm limited on space. So an articulated microphone stand is probably a good choice for me. So one of these articulated stands comes with a clamp to attach it to your surface, the arm itself which has an attachment for the microphone, and a place to actually connect it to the clamp. And the cool thing about this is, as you move the arm, everything stays in parallel. So it makes it really nice to actually adjust. So before we get started designing, let's take a look at the requirements for this particular build. So firstly, we have the staple live streamer camera, the Logitech C920, and this is my secondary camera. What I try to do is to get this position so that it captures the project that I'm working on. Trying to get it something where it's looking at the project and get it in shot. But what would be ideal is to have hands-free sort of overhead shot, or the ability to move the camera in sort of any orientation. So that's where the microphone stand comes in handy, because you can articulate it to any position. So in addition to that, we have this microscope camera, and that will get us really good close-up shots of any sort of electronics. However, the way this is set up, it has a stand that connects to this cutting mat via a suction cup. So you place your subject on it and then you bring it down and focus it in. But then it becomes quite cumbersome if you need to move things around. So we need something that will hold both of these cameras and articulate and move them around to my liking for the shot at any given time. So I'm modeling this in Fusion 360, but you can choose any CAD application you are familiar with. And we start by modeling the stub that the mount will actually fit to. And that gives us a point in space that we can model around. And it's a case of just drawing up some sketch parameters, such as the hole that will take the 1/4 screw that attaches to the C920, and the placement of the microscope camera. Once we've got the sketch all designed, we just extrude that into 3D space. So then, using the hollow function, we hollow out the part and use the rib function to model in some reinforcements. So with the part now fully designed, we output it and send it to the 3D printer. So if you don't have access to a 3D printer, that shouldn't stop you from designing things in CAD and getting them printed out. You can use a print-on-demand service such as Shapeways that you can make a design, upload the file, select your material, and then once you're happy with the costings, you can then have this printed out and sent to your door. So I encourage anybody who's thinking about getting into 3D printing to start with the CAD. Start learning CAD application so that when you do get a printer, you're not just using it like a toy printing things out of Thingiverse. Learning the CAD turns your 3D printer from a toy to an extremely powerful tool. So let's get this put together. Now we've got the cameras mounted, we need to get these hooked up to the PC, which is where we find one of the first problems. So my PC is down here on the floor and the cables are pretty short. Now they've been zip tied neatly down the mic stand. We have a problem. So to fix this problem, I picked up a power mount USB 3, got 2 USB ports in it, and we've got around about 1.5 to 2 meters worth of cable. We now need to make something that this will go into and mount to the desk. This is the end result. So the USB clips into a faceplate. That faceplate screws into this unit here, and the cable's actually threaded through the inside of the unit. Essentially, this is going to mount on the desk. This, meaning have easy access to the USB ports, cables will quite easily reach. So now we've got everything hooked up, let's see how the cameras perform. So this is the overhead shot. This gives us a nice field of view that we can work on. I can work away quite nicely here without the camera being in my way, but everybody gets a good view of what's going on. So for example, we can bring in a project and we can work on it here. Now what I can also do is bring this down and give us a different perspective on the situation. So I can continue to work here with a different view, and I can move this around to different positions, give you a first person point of view, and I can work away no problem. No issues around working with this at all. This is really, really cool. So what we've done here is we've moved the camera to a different position. So it's now facing towards me, and we can get some really good action shots of, you know, a piece of work that I might be working on, like this leather wallet, which I have a video for. As for the microscope, the camera is fully extended up and it gives us a really nice close-up view of the display without the camera being right in around the area that we're trying to observe. And what I can also do is bring it down really close and we can look at really minute detail. So one of the downsides to the microscope arm is that there is a little bit of vibration that is being picked up by the microscope. So if I tap the desk, the image does shake a little bit. So that is one of the things that is a bit of a downside. So all in all, I'm happy with the result of the project. It's been low cost, it's been relatively easy to do, and I think it's something that other people could actually replicate and suit to your particular needs. So if you like the video, give it a thumbs up, give me a subscribe, and I'll catch you in the next one.